Hello friends, welcome to Cloud Pedagogy. Thanks for joining me in the AWS course of this session. In today's session, we are going to discuss about EC2 user data and metadata. So, what is user data? AWS user data is a powerful feature in AWS that allows users to pass initialization scripts or cloud config files to EC2 instances during the launch. These scripts can be written in various languages, scripting languages such as Bash, Python, or PowerShell, and they can enable users to execute a series of actions automatically upon instance boot. Amazon EC2 does not put this user data on the instance directly, though many AMIs have code that instructs the instance to download and process the user data automatically. In our student directory application case, we have configured Python and its libraries, and then we have provided a set of bash commands in the user data field of AWS EC2 config page. So after launch instance, this will initiate the creation of the EC2 instance with the specified configurations and user data. After you launch the EC2 instance, you may think how and where is my code really running? When we create a new EC2 instance, most of the EC2 instance families provide us with a virtual machine that gives us resources such as vCPU and RAM. This virtual machine runs on a physical server within an AWS facility. In AWS, we call this server as a host. A hypervisor mediates access between your code and the underlying server and provides isolation from other workloads that may be running on that same machine. This host is physically located within an availability zone. That's what AWS calls a logical grouping of data centers. For EC2, you get to select the availability zone in which you run your workload. So that's about the user data. So what is metadata? Imagine that you have a locker at home with some precious items inside it. In that case, do you leave your locker door unlocked just because you locked the house door? It's the same thing with IMDS. It is like a locker containing precious information about your cloud. It is important that you understand IMDS and how to secure it. It's time you take the instance metadata service, which is IMDS, very seriously. So what is EC2 instance metadata service? The instance metadata service helps code on EC2 instance access instance metadata. IMDS provides a great amount of information about instances. This includes hostname, security group, MAC address, and much more. It also hosts user data that you specified when launching your instance. For an attacker, this is a gold mine. You should understand the security implications of instance metadata service. This would help you to better protect your cloud. The IMDS exposes this instance metadata through a special local link IP address of 169.254.169.254. Hence, only code running on the instances would be able to access the metadata. Securing IMDS becomes critical due to its availability to access the AWS access credentials from the IAM role attached to that instance. So how does AWS credentials works on EC2 instance? The applications running on EC2 instance must sign their request with AWS credentials. One way is to provide the credentials in the form of AWS access keys or secrets. For various reasons, this is not a recommended approach. It is cumbersome to distribute or rotate access credentials on each time. Even more challenging is to distribute and rotate the AWS created access credentials to the instances. For example, spot instances or auto-scaling groups. Instead, you can attach an IAM role to the EC2 instance. That's what we did in SDA application. The advantage is that you as an application developer don't need to bother distributing and rotating the access credentials. The IAM role helps to enforce the least privilege principle as another advantage. The resource level permissions in IAM policies help you decide on a granular level what IAM roles users can attach, detach, or replace for an instance. In general, using IAM improves the cloud security posture. So, what is an IAM instance profile? To pass an IAM role to an EC2 instance, you need to use the instance profile. You can think of an instance profile as a container for the IAM role. You can attach or detach the IAM role to the instance profile. The instance profile itself can be attached or detached from the EC2 instance. The question arises is, what is the difference between IAM role and the instance profile? Why do we need a container around the IAM role, right? Only IAM principals or identities such as users, groups, AWS services, etc. can assume the IAM role. The users, groups, AWS services represent who assume that role. The EC2 instance itself cannot assume a role, right? Hence, AWS creates instance profile as a principal to assume the role for an EC2 instance. The only thing the instance profile does is to assume the role attached to it. Beyond that instance, the profile has no other real power. The instance profile derives all its power from the assumed IAM role. So, how to retrieve the metadata from EC2 instance? When you switch to connecting to EC2 instance, then you can explore some of the instance metadata. Once the instance is running the state, if you click the connect button in the console, you will get run commands to see the metadata of EC2 instance. This service can allow you to deploy to an EC2 instance to customize itself. We will begin by running a curl command to a special IP address, which is private. That is 169.254.169.254 is a special IP address that is within the range for local addresses. So that this request will be picked up by AWS and the response will be customized for the EC2 instance making the request. But these can also return the access credentials. All these calls work without any authentication. It's like keeping the locker open thinking no outsider can get into your house. Of course, that's definitely security concern, right? So let's see what makes IMD SV1 risky. The instance metadata service is accessible from the instance only. Once you have access to an EC2 instance, you wouldn't need any further authentication. You have already proved the ownership and no extra authentication is thus needed. In theory, IMDS metadata will not be available outside the instance. If the EC2 instance is open to the outside world, attackers have a chance to steal credentials. Attackers use server-side request forgery, XML external entity injection vulnerabilities to steal. Even shell access to the instance may expose access credentials. The SSRF attack happens through a vulnerable web server running on the instance. For example, a web server running on the instance may accept GET request, which may get redirected as a request to the IMDS endpoint. The response would in return the IAM credentials. The attackers sure enjoy using these credentials, right? In most such cases, the reverse proxies such as Apache HTTPD or Squid or web application firewalls are misconfigured. These misconfigurations expose the metadata service to the outside world. IMD SV1 cannot stop the IP packets containing the response to crossing out such as EC2 instances. But that's where IMD SV2 comes into picture. This prevents packets from crossing out of the EC2 instance. The IMD SV1 requests are not authenticated and are susceptible to SSRF attacks. But the newer version, which is IMD SV2, adds protection against SSRF. IMD SV2 also requires users to create and use session tokens. So while establishing a session, users can specify the session duration. The longest allowed session duration is of 6 hours. These session tokens are valid only for that specific EC2 instance. This session always starts with HTTP put request. The request also has a mandatory HTTP header. This header specifies the maximum time the session can be valid. So that's all for today's session. In the coming exercise, you will have an opportunity to explore some more instance properties as well as poke around some of the logs for debugging. So that's what we are going to discuss on the next session. And I'll see you again in another session. Until then, take care.